Hello, everyone. Welcome back to SAT Math Question of the Day. Here we go. Here's the question. Please read it, try it, pause it, come back, and we'll do it here. We'll try to do it here. Okay, we have two functions. They're exponential. Okay. Wow, they only differ by the sign of the leading coefficient. A graph on the xy plane. If AB is a point on the graph of f, then which of the following is a point on the graph of G? Wow, so this is sort of a conceptual question. If AB is a point on F, then which of the following AB? But there's a negative sign here, so isn't it A negative B? Because the output is negated between the two. So wouldn't it be this?
Yeah.
Yeah. Right? Because
Yeah.
G of x is equal to the negative of f of x.
Yeah.
Which means that G of A is equal to the negative of f of A. But G of A is B. And not G of A.
F of A is B.
F of A is B, right. So G of A is equal to negative of B. Right. Which means that the point is A negative B. Wow, look at that. That's a fancy methodical way of doing it without just looking at the answer. Right.
Yeah.
So this can use the idea of composition of functions. This can use the idea of reflections across the x-axis.
Yeah.
Uses the idea of this whole thing of if you have f of x, what happens to a function, let's say, a f of x plus b plus c. Right? If you have f of x, then if you change it around and you throw a coefficient in front and you do f of x plus b and you add a c to it, where does the function go? So it's related to that. Yeah. So it'll be interesting to see how they do it. So this will be the answer. We never really. I mean, this is an algebraic thing, but I remember when we like to talk about when we went to school. Don't you hate those people who talk about that? Did you really get into the stuff about transformation of functions in high school when you did math? Because I definitely did not. And I'm just wondering if that's a new thing that they're bringing in the curriculum. But I don't remember ever really overdoing it on this idea of how a graph changes by changing how a function changes by, called transformation of functions, how a function transforms when you make tweaks to the different parts of it. Jim, do you remember doing that in high school?
Yeah. But
Really?
many things they did.
Really? Because I don't remember doing that.
Yeah.
Well, anyway. Do you have any other thoughts, Seth?
Well, that's like a fine way to approach it. Yeah.
It's funny because it really has nothing to do with graph. I mean, it does and doesn't have to do with graphing. They didn't really have to say.
I think the fundamental idea is this statement: AB is a point on the graph of F.
Right.
Means B equals f of A.
Right.
Which is the formula that you use.
Yeah. We could, since it's a graph and since people have a graphing calculator and people may be tempted to graph it, we could look at it from that point of view also, can't we?
Why bother? We have F is
Oh, I drew the X.
Is negative, and it kind of it says exponential decay on the positive side and exponential growth on the negative side. So this is y equals -2 times a third to the x. And you just flip it over. Just take a given value here. Here's a on the x-axis, b on the y-axis, and then minus it. Goes up like that.
Well, no, what you could do then is if you have
it just so the graph's minusing. So this curve. Let's say take up out of this curve. This one.
Right. There you go.
Is y equals 2. Minus
positive 2. Positive 2.
Of -2.
Right.
Third times a third of to the
x
power.
Or this graph. This graph is equal to y is equal to 2 to the 1/3 to the x power.
Yeah.
And then you can see, right, if f of AB is a point here, if this is point AB, then which of the following is a point on the graph of G?
Yeah.
Well, you go down here. The A stays the same, and the B gets negated.
Yeah.
I mean, this is the graphical approach to this. We should also have done this. I don't know why.
Yeah.
I mean, this is not a bad way of doing it.
Oh yeah. So this green thing. It's what you erased at this. I'll use green. I can't use green now. Yeah. Green. Where's green? I'll use green too. The green thing is this property.
Yeah.
Equivalent to B equals f of A.
Right.
Is and then so flipping it over. Yeah.
Okay. So I think we've done it different ways. First, we did it algebraically.
Yeah.
But the algebraic experience, I know that I presented, I really only got it by also knowing in the back of my head the graphical approach, the graphical understanding of what happens when you put a negative number in front of the function. This A thing here gets a negative number.
You multiply the function value by a negative by -1. It flips it over.
It flips
the graph vertically.
It flips it.
So similarly,
it flips it across the x-axis.
If you negate, if you negate every appearance of x, you flip the graph across the y-axis.
That's right. Oh yeah.
And now if you interchange x and y, that flips the graph across the positive diagonal.
Right. Yeah.
Right. And then if you replace, say, x by y and y by -x, then it flips it around the negative sloped diagonal.
Okay, so let's see how they do it. It'd be interesting to see if they do the graphical approach where they graph the two, or if they do it entirely algebraic.
Yeah, let's
see. Maybe they'll do it both. They really should do it. If we were writing the book, we would do it both.
Yeah, they don't do it 2 ways.
I know, they don't do it 2 ways. Okay, let's see how we answer the question. Oh, look, they did the graphical approach. Wow, look at that.
Yeah.
Notice that f of x is negative g of x. That means that for all points f of x on the graph of x, the point, So they do it both. They do it both because if you do it with method one, their step one, you don't need the graphical approach. There's the answer right there.
Yeah.
And now they are doing it both ways. Wow, look at that. Yeah, so they really are. They are doing it both ways. And then they graph it, and then they show how it works. Except you don't have to graph it exactly. You could just graph it roughly like we did. But I think you get a graphing calculator on the digital SAT, and this comes from the digital SAT practice. But it takes a lot of time to sit there and graph it. I mean, I would think it takes a lot of time to sit there and type the function in. Do a graphing calculator. You got a lot of parentheses. You got to really make sure you write it correctly. But if you have a lot of experience using the graphing calculator that's on the digital SAT, then you could graph it quickly. And that may be a good idea to do, is to practice on the actual calculator they give you on the digital SAT. Because this comes from the digital SAT practice. So, I'm Joel Chaiken. I'm here to do a PhD in mechanical engineering. My brother's here. Sathi has a PhD in math from MIT and a professor emeritus at SUNY Albany. And we're here to basically go over how to approach SAT math questions. We take the point of view that, one, it's a math question, so we do it completely, but we also are cognizant that the question has to be done in a very quick time because it's a time test. So we also try to do the problem as if one were taking it with a time pressure. Sometimes the approaches are the same, sometimes the approaches are different. Okay, what else? Approaches for studying for the Math SAT. We suggest going to Khan Academy. They have 2 courses. They have the digital course and the non-digital course, depending on which test you're going to take. They have like 600 or 700 math questions. Do them, practice, and then practice them before you start practicing on the digital. Before you start practicing on the SATs that the College Board gives you, of which you should practice on all of their tests. I guess that's it. Please dislike, please give us comments on our videos, and if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, everyone, have a great day.
Hey, have a good day.
Have a good day.
Nice.